Hello, Chem 111. This video is about drawing molecules using what's called organic shorthand notation. As you'll see a little bit in this class, and more so if you move on in chemistry to take organic chemistry, organic molecules can get really big. So it becomes cumbersome to try to draw out every single atom label. And so we have a simplified strategy for drawing organic molecules that allows us to draw big structures in a simpler way. So I've written out the steps for doing this, and we'll go through a few examples together, and then I'll give you a bit of time to do some practice problems that I'll give you here. Okay? So there's really two basic rules for this. The first is that we're not going to draw any carbon or hydrogen atom labels. We are, however, going to draw all other atoms like oxygen, nitrogen, sulfur, etc. All right. So that means that some carbon atoms will look like they have fewer than 8 electrons around it. So we assume that all carbons need to make 4 bonds. Okay, so any carbon that doesn't have 4 bonds, we assume there are enough hydrogens to give us 4 total bonds. Okay. So we're going to represent carbon atoms as vertices, or a point where 2 lines meet, or at the end of a line. Okay. And I just want to make one small note here that sometimes organic chemists leave off lone pairs. So for example, if oxygen had some lone pairs on it, we would just not draw it to simplify the structure even further. For this class in Chem 111, we're going to leave lone pairs. We're going to keep drawing all lone pairs, so we don't need to worry about that. But I just wanted to make a note for future that sometimes we leave off lone pairs too. All right, so let's do some examples to illustrate these concepts, because I think that's the easier way to wrap our heads around it. So if we look at the structure drawn in A here, I like to number my carbons because I'm an organic chemist, to keep track of how many carbons I need to draw in my simplified structure. Oops. All right, so the first carbon over here on the left, we'll label 1, 2, and 3. All right. So that means that the structure I'm going to draw for this molecule should have 3 points. Okay, and to do that, we'll just have 2 lines connected at a vertex. All right. When I look at this structure, what I'm seeing is carbon 1 here on the left, carbon 2 at the vertex, and carbon 3 over on the right at the end of the line. All right. The other thing is that we're not drawing in any of the hydrogen atoms, so we're technically done with the structure here for this 3-carbon molecule. But I just want to mention that we assume there are 3 hydrogens on carbons 1 and 3, right? Because we need 3 additional hydrogens to get us to 4 bonds total in those positions. We assume that carbon 2 has 2 hydrogens on it because it needs 2 additional hydrogens to get us to 4 bonds total around that carbon. Okay. So I'll just redraw here. The final structure here would just be something like this with a vertex connecting 2 lines. Okay. All right, let's look at the structure in part B. It's a little bit more complex. In fact, it's got quite a few more carbons. So I'm going to go ahead and number my carbons here. And we've got a ring structure connected to 2 additional carbons. Okay. So if I just start over here and label this carbon 1, 2, 3, 4, 5, and 6, we've got a 6-membered ring connected to carbons 7 and 8, positioned outside of the ring. Okay, so to draw this in organic shorthand, I'm going to draw a polygon to represent the ring, and since it has 6 carbons in it, I will draw a hexagon to represent the ring, and then I'm going to draw 2 carbons outside of the ring. So if I just use my numbering scheme here, I've got 1, 2, 3, 4, 4 comes before 5, and 6, 7, 8. Okay? So if I look at the structure on the left, I see that there are double bonds between carbons 1 and 2. So I'm going to add an additional bond here, between carbons 3 and 4, and between carbons 5 and 6. Okay. Carbon 7 is also double bonded to an oxygen. So I'm going to draw that in and keep the lone pairs on my oxygen atom. All right. So again, we're not drawing in hydrogen atoms, so we are done with this structure. So without the carbon atom labels, which again, you don't need to draw, I just find it helpful to keep track of number of atoms. This molecule right here would be your final answer for drawing in organic shorthand. All right, here are 2 sample problems. The first asks you to draw the molecule shown in organic shorthand, which is essentially what we just did. And then in the second problem, I ask you to convert the organic shorthand structure and add in all carbons and hydrogens that are implicit but not shown. Okay, so go ahead and pause the video and you can work through these 2 and then check out my answers. All right, so like I did before, I like to just number my carbons so I can keep track. So 1, 2, 3, 4, and then an oxygen. So we need to draw zigzagged lines to indicate the carbons, right? And I'm going to draw, I guess, 4 lines. And we've got carbon 1, 2, 3, 4, okay? And then the oxygen atom is here at the end, all right? If we look at the original structure, we've got a carbon-carbon double bond between carbons 1 and 2. So I'm going to go ahead and add in that double bond, right? And then we will add in all of the lone pairs onto the oxygen. It has 3 sets of lone pairs, giving it an overall -1 formal charge. And then again, we're not drawing in any of the hydrogens, so this structure here would be our final answer in organic shorthand. All right, let's take a look at number 2. So here, I'm going to start by numbering all of the carbon atoms. Okay, so if we start on the left side of the structure, we've got carbon 1 at the end of the line. We have a second carbon at the vertex that's double bonded to the oxygen. Then we have a nitrogen atom, and then 3 carbons over on the right side of the molecule. Okay, so now let's draw the framework showing the carbon atoms. All right, and I'll use my color scheme here. So we've got a carbon bonded to the carbon that is double bonded to oxygen. All right, I'll go ahead and add my lone pairs on oxygen. And then we have a nitrogen atom, also with a set of lone pairs. And I won't, whoopsies. Let's get rid of that and make it white. All right, nitrogen bonded to hydrogen. And then go back and add in our other carbon atoms over on the right side. So we've got 3 carbon atoms over here. All right. So again, we have 1, 2, 3, 4, 5 carbon atoms. So we've got everything, all of our carbons there. So now we just need to add in the hydrogen atoms to indicate how many are on each carbon in the structure. If we start with carbon 1, remember that we want every carbon atom to make a total of 4 bonds. So any bonds that are missing will be hydrogen atoms. Okay, so carbon 1 needs 3 additional bonds to bring it up to 4. That means we have 3 hydrogen atoms on carbon 1. Okay. Carbon 2 already has 4 bonds to it, so we don't need to add any hydrogen atoms there. So we skip over nitrogen and look at carbon 3. Carbon 3 currently has 3 bonds to it. So that means it needs one hydrogen atom to complete its 4 bonds. Okay. Carbons 4 and 5 both have just one bond to the carbon next to it. So each of those need 3 additional bonds to hydrogen to bring us to 4 bonds to each carbon. Okay? So this would be our final structure in which we're showing all carbon and hydrogen atoms. All right, so this video gives you an idea of how we simplify big structures that contain a lot of carbon and hydrogen to make simpler structures for reading and drawing.